So mine's bought a £200 switch and just dropped it on the floor. Okay. Oh, shit, my screen. Stop.
I'm watching this. She's on hibernation.
Yeah, well, I think hibernation might be a reason. Okay, folks, here we go. The objectives of this chapter are: explain the purpose of dynamic routing protocols, how they're used, both dynamic and static. We look at something called RIP version 2. Look at the components of an IP4 routing table for a given route. What is a parent-child relationship in a dynamically built routing table? Which routes used to forward an IP version 4 packet and one that uses an IP version 6 packet. You'll do some practical work with working with a topology and looking at configuring RIP. We'll look at troubleshooting too and problem solving. There's a lot of interactive activities in this actually inbuilt into the materials. Okay, and that's your general headings. There we go. So starting with dynamic routing protocols. Last week we did the static routing protocols, and there's a little summary of like kind of why you'd use one or the other. So we talked about the advantages of static routing. Please do. Oh look, here he is. Hello. How you doing? You all right? Take a seat, man. How's the test coming along?
Not yet.
I know.
Yeah. I just completed the lesson of
Oh, the materials, yeah?
Yeah.
Okay, good. Okay, make sure you keep up to date with those things. So static is easy to implement in a small network. Yes. Very secure. There's no advertisements. Okay, so you'll hear about advertisements in a minute. The route to destination is always the same. Because there's a known static route with IP address, no need to calculate or update or do algorithms or use any of the CPU processing power of the motherboard or the processor of a router or switch to handle this. Disadvantages, they're really only for small topologies, simple, small business type operations or small kind of like office setups. Or for special purposes, such as the default static route, which is the one, for example, we use for the internet, if things fail. As networks grow, you get more complex with static ones, and a manual intervention is required to reroute traffic. If something changes on the network or topology, you've got to manually do it again. So here we introduce now, because of those disadvantages, the concept of dynamic routing. And there are various protocols for dynamic routing. They've got slightly different names on version 4 and version 6. So we've got both interior gateway protocols and exterior gateway protocols. Okay, this is within a network. This is when you go beyond between internet service providers. You can imagine, like, you know, we're like in a college network here, and we can communicate internally with different servers and devices as we need to. Once we go onto the internet, it's a very different control mechanism. And between our ISP and another ISP, like take BT Internet, ours is managed by something called Janet, which is the educational network. Between Janet and BT, they have their own protocol of how they exchange data and route it into different directions. And also the frequency of routing too. So RIP was what it was first called, was updated later to version 2 to help with growth. And so it does not scale to current larger network implementation. So again, it's like a medium-sized scale. And that's one of the various things you'll learn about. EIGRP is another routing protocol. There's one called OSPF, one called ISIS, and one called Exterior Gateway Protocol. Border Gateway Protocol, indeed. This is what ISPs like Janet and BT Internet and O2 or what the other, Vodafone, etc., are using those to communicate with each other. Okay, OSPF stands for Open Shortest Path First. It's like a mathematical calculation. Then you've got ISIS and EIGRP. Okay, so looking at what is the kind of purpose of these dynamic routing protocols, they help to discover remote networks. They maintain up-to-date routing information. They choose the best path to destinations, and they can find a new path if the current path vanishes, no longer available, something's deactivated, device failure. They can actually do that and work around it. Static cannot do that. So these are actually way more robust for that reason. The main components of dynamic routing protocols are three things, okay? These things you need to remember. Data structures. We keep a database in the RAM, okay, of the routes. Routing protocol messages. How do we discover other routers? How do we exchange information with other routers? How do we maintain current and up-to-date information about the network? Finally, how do we work out the best path and learn routing information? These are algorithms and mathematical that do that stuff. Networks often use both a combination of static and dynamic routing. You might need to make static routes to devices like printers or the internet. You might need dynamic routings to keep up to date with what's going on. Topology is changing all the time. So as we mentioned before, if you remember from last week, static routing is used for easy routing table maintenance, connecting to a stub network, or accessing a default route. And here's an example of why you might want an access to a default route, okay? Because this might not know what to do with other networks beyond these ones, okay? So there's your default route there to get beyond it. R1 here, I need two networks I need to know about, this one and this one. So because they're both stub networks, they're on their own, no more routers beyond this. This is appropriate for having static routes for those. Okay. Here it's saying R2 is connected to other networks. It's my only way out. So default static route is used to reach any network I don't know about. There you go. That's how you get to there. Is that ready? My God, what's going on here? Wow. Okay. So dynamic routing is the best choice for large networks. And they also help the administrator, because the administrator hasn't got to worry about all these manual changes and constant updates. Also, the administrator needs to worry about redundancy. If someone just failed, there's a backup plan. So it gives redundant paths. What does that mean? A redundant path. Not quite, no. Think what the meaning of this means. What is a redundant path?
The past.
Redundant.
Yeah, redundant. Actually, what do you think of redundant? It's something you used to do previously.
Yeah. Good definition.
Probably be the previous role.
Good definition. It would suggest no longer needed, right? No longer needed. But it is needed because, like if I had, for example, this here, right? See this little setup here, right? I can go from this router to that router a number of ways, yeah? So you see this, right? I can go like this, down to there, yeah? And if you look at the diagram carefully, there's other ways of doing this as well, right? I also can go that way, there as well. But because I can do this and this both ways, you might think, oh, one's redundant. Why do I need both of these things? Why do I need both of these things? Okay, if that one broke, I have that one. If that one broke, what remains? That one, right? If both of them break, there's actually nothing else on this side of the network. There's lines in the middle of it, right? So, that's a redundant path. You have these two working together on this one. There's no third path. If they both fail, then we're in trouble, right? But we do count for like one device failure, not both of them in most cases. So having an alternative path is the reason why we do this. So the advantages of dynamic are suitable in all topologies where you have multiple routers, independent of size, and adapt to reroute if possible. They are more complex to implement. They're less secure. Need much more configuration and skill for the administrator. Depends on the current topology. Whatever you've got, it does define what you already have. It does require more power for CPU, RAM, and link bandwidth there. All right, good. There you go. Okay. So configuration, folks. We know it's not going to config sort of like options and methods. So to really enable our RIP1, version 1, we do router, we do conft get in terminal, and do router space RIP. Okay? And to disable it, it's no router RIP. There's a way back out of it. There's some configuration commands. I'll zoom in on these so you can see them. If you ever go to R1 and do a question mark, you'll get all the possible things you need to configure. Okay, and these ones that are highlighted are the ones: auto summary, default information, network, passive interface, version, are ones that are sensibly appropriate for RIP config 2, and things you might want to do with routing protocols. So one of the things about when you have a kind of a situation like this, let's take an analogy here. Let's just say you move house, and then you go somewhere else to live. Yeah. What do you do? What's the process of like telling your friends that you've moved? What happens? Some of the just real world things you might do. If you're polite about it, that is, anyway. What might you do? When you move house, what happens? Yeah. You might do an electronic one nowadays, right? Yeah, like I'm moving house, blah, blah, blah. And what information are you going to provide them? Yeah. So if you were at old address, I'm moving to a new address. Okay. So effectively, what you're doing is you're kind of advertising your move. Yeah. And like in a dynamic network or that kind of situation, the networks jump about all the time. There's also things changing all the time. So what needs to happen is you need to be able to advertise. As a router, you advertise to other routers where you are, who you are, and if you're moving about, where your current status is. So what you do is you would, first of all, the command for advertising is you first have to configure, do router space, okay? Then you then after that you then configure the commands to advertise networks. So if I see here this router, looking at R1 here, okay, I'm advertising 1.0, okay, and 2.0 to my neighbor routers, which are R2 and R3. Whoever's around me, okay, that I can get to is what's getting the message. So the interfaces, okay, crucially involved with this, okay, they belong to certain networks. These routing advertisements are sent to routers every 30 seconds. Okay, that's the frequency of update, which is pretty good.
Can you change the timing? Or
you can actually, you can change the frequency, I believe. And yeah, you can take it higher and lower.
Does that use like resources?
On microseconds of the actual thing happening, no, not so. But every 30 seconds or a minute is not so bad. It's pretty useful to do that. Yeah. Look at the networks of today and how frequently devices are coming on and off line, particularly with Internet of Things or with our mobile tablets and phones all the time, right? And things like that go to Wi-Fi. This is usual in a home environment. Okay, now when you advertise your networks, how do you verify them? How do you verify it's taking place? The show IP protocol is the ideal one to use. This will show you what's going on, the kind of routing happening, and it will tell you also the type of protocol active. Sorry, but it's hard to read that. Look at the first piece of it. Can you go on the first one on your left side? Yeah. It's far left, actually. Oh, you've done it, marvellous. Right, so there you go. So we've got here the routing protocols RIP, how frequent your updates are, when the next one's due, tells you about your interfaces and also what networks you're routing to, and the distance. I think they're just highlighting it's all black and white, isn't it? Just highlighting these commands are important. Yeah, Cisco materials. There you go, and also the distance between the source of routing information too, and how it was last updated. Okay, so it shows you what's on there. Show IP route, the other one. Let's look at this. What this shows. It shows you the IP, the RIP routes installed on the routing table. So there's a one R is RIP. Okay, it's 3 there. 3, 4, and 5 on R1. It's showing you the other networks that were out there and beyond itself. Directly connected, variably subnetted on there, and there's your RIP ones also. There's 2 commands for you there. Okay, now R2 also needs to be configured also with RIP. Once you were doing a protocol, you can imagine if you're doing a protocol on one device, the other devices must also have it running too. Hence the idea of protocol. If I'm speaking French and the other person is speaking German, we ain't going to communicate. Well, not very well anyway. So what we need to do is make sure everything has the same protocol set up on both sides. R1 has been configured already, okay, and it's already been set up. It's actually we've got a version thing also. This is our RIP version 2. What we're seeing here is R1 being configured with router RIP, and then you do version 2 to make it RIP v2. Yeah, and then you're gonna there's like a little test going on there also. So that's how you get the latest version of RIP running. You can verify with the command below. Hello, oh no, exactly. Surprise, surprise. I'm watching you. Take a seat and join us, and we'll just be right where we're at. And I'll chat to you a bit more in the break, I think. We're just in CCNA chapter 2, chapter 3. How you RIP. Yeah? Yes, I've got this recorded actually, all the next YouTube or WhatsApp. And what we some of the other things but people won't do that. They want to provide the service first instead of stuff. Might be simple, yeah. Use Fridays. You probably like to quite quickly with it. Yeah, therefore maybe it's differences happening in April. And then our good exams will be happening in May. Come on. So there's your, that's how you do your routine. Yeah, sorry. There's some chairs here, by the way. One second, folks. One over there, spare. That one over there. So verifying grip, that's what we do. Okay, now, remember I did mention a concept of summarization in the previous class. Who can remember what I mentioned about summarization? Thank you, Betty. Go. What is summarization? Your hand was up, I thought. unless you're stretching. Oh, was it? See, well, now you've got yourself in trouble, haven't you? Now you are in trouble.
Summarization, as I understood, is if the network portion of the address
very good
is the same to most of the for example, in a LAN, instead of advertising every single license, they do not need to advertise therefore they will have only one exit. That exit is matching the network address portion of it.
You kind of got that, right? You kind of got it. So when you have a network boundary, okay, and various subnets and subnetworks often, you don't have to write every single network. You know each network address. What you can do, like you said, is you can use the network portion of an IP address, and in a way, a bit like masking, you can sort of give a much you can use some of those bits to summarize all those subnets inside it as well, which is one way. Okay. Now, RIP version 2 automatically summarizes networks at the boundary point. Okay. You can disable this. I'm not sure about why you want to disable it. I mean, there's some reasons for that. But you can disable it also. You can verify it's been switched off, or even if it's running or not. It's already switched off from the start. Okay, but it has this automatic ability to summarize network at the boundary point. For example, boundary point is here, has access to 3, 4, and 5 network here. Okay. Now also, there are also something called passive interfaces. So when you've got a passive interface, I might show an example of one here. This one here, router RIP 0R1, is being configured a passive interface G00. So the word passive tends to mean not active, right? Okay, so you don't really need to have a On this interface, you may. On this interface here, one towards a switch, okay, does not require you to be RIP enabled. Yeah, RIP is good routers talking to routers. It's a router protocol. It's not a switch protocol. Yeah, so if I'm talking to a switch, I'm going to make my interface to that passive. Right, you're alive.
So this passive interface means
It well, just means that if you're say setting up RIP on a network, which is happening here, okay, by default RIP goes out for every interface. By default for every interface outwards. But when you've got like a passive, which means like going say a switch, for example, in this situation, you don't really need to have an update going in that direction. Again, as you mentioned earlier on, the use of processor in those micro updates every 30 seconds does waste resources and bandwidth. And it goes up quite, if you run Wireshark and watch it, you see a lot of stuff being used up on just that alone. Okay, so what we do is we are preserving energy, you can say, and rather than having it forward out, I think we can turn off on passive. So here's the example of it. All these ones get it by default, but we really only need to send it just to ones that are other RIP routers, which is that one and that one. And that's even beyond this. It wastes resources, also security risk, so we use passive type of interface to stop routing updates out the interface. Okay, that's what stop advertising to other routers in this direction. Just that direction. Just an efficiency. Okay. Sometimes with having RIP and deep dynamic route, as I mentioned before, you also something called a static route. And as I go here, we need a static route to the internet. And it's already configured on R1. And what this is showing is, okay, an example of how the default static route can be sent out to other routers also in update. So if I know my way to the internet, R1, and I want to share it to other routers, like R2 in the business, okay, and beyond, I can share it. And the way I go about it, I'll show you how this command works. So I first configure, okay, my connection from R1, my default static route. This is the quad 0 configuration. IP route quad 0 S001, which is that little dot there, that red line. Okay, so serial line 1 there. Okay, and it's going to, sorry? Next hop address, well, it's going to 209.165.200.226. Okay, and that code doesn't actually annotate this very well, by the way. This is quite badly drawn. This needs to be over here. Whoops, oh dear. Anyway, this should be over here, and that red line is going to that address with 226 at the end. That's a network address, by the way. So this is the device. So you do your static route first, your default route, then you do your router RIP. Okay, and now what I'm doing is I'm saying any information that I've got, okay, of my default routes, default static routes, I'm the originator of them. You can now share this. I'm showing it to all other routers that are in my neighborhood. Okay, so my internet connection, default -information originate, is now going to get pushed out to other places too. Okay, and now in this little show IP route here, now we can look up the word gateway. Okay, which is the old gateway to last resort, and here you see gateway of last resort is this IP address to that network, which means all addresses not catered from the network can be sent to the internet to be resolved. All right, 29. All packet tracer coming up now. Here we go, doing a RIP configuration, and the lab will finish it sooner. So let's now get into that. Okay, can you please bring up the packet tracer? 3218. And that should be doable for you, and it's actually quite straightforward. All right, that's 31 to do. If you haven't done this already, haven't done a little, if you haven't done it already, please move to the lab. I think you're all doing it for the first time here. Okay, good. Or 31. Let me just look at this video now. Part 1 of that.